Continuous data, or scale variables, give us a clear window through which to see the world, allowing us to measure differences that we cannot see with categorical data. We are going to learn how to create descriptive statistics for continuous data in IBM SPSS statistics. First, I should tell you where you can find these data. In the description for each of the videos in this series, you will find a link to a Google Drive folder. Right-click on any dataset to download it to your computer desktop. Choose the dogtoys2.sav SPSS dataset. Double-click to open the dataset in SPSS. Now, in the field of statistics, we use numbers to understand the world. I told you that numbers generally do one of three jobs. Nominal data define differences between groups. Ordinal data define differences between groups and show the direction of difference, higher or lower. Both nominal and ordinal data are categorical data. The third job that numbers can do is to show differences with a direction and measure the magnitude of the difference. These numbers are variously called quantitative, numeric, or continuous data. But I will call them scale data because they have an underlying scale with equal increments between the points. There are two kinds of scale data, and the difference between them is whether or not they have a true zero. If the data are on a scale that do not really have a 0 point, such as IQ, personality measures, or GRE scores, or if they can have values less than 0, negative numbers, such as temperature in Fahrenheit or Celsius, then they are called interval level data. But if the scale data have a meaningful 0 point, which cannot include values less than 0, such as height, weight, dollars, or temperature on the Kelvin scale, they are called ratio level data. Ratio data have an absolute 0, in which 0 represents a truly meaningful absence of the thing being measured. Whether interval or ratio, scale data can be described using the same descriptive statistics as with categorical data. Simple frequency, percentages, numbers, tables, and graphs. But we also have more exquisite measures for scale data. For our hypothetical dog toys data, we surveyed 50 dogs about their love of toys. We asked them how many toys they owned and which was their favorite toy. We noted each dog's size and breed. And then, as a thank you for participating in the survey, we let each dog choose one of three gifts: a hedgehog, a duck, or lamb chop. For that gift toy, we kept track of how long it took for the dog to chew the stuffings out of the toy, which we recorded as days to failure in our data set. We have two scale variables: number of dog toys owned and how many days until failure of the toy. Both of these variables have a scale. They tell us how much or how many. Both have an absolute 0. There are no negative numbers of days or dog toys. So both of these are scale variables at the ratio level. I said before that all of the analyses in SPSS use the Analyze menu. But that's not quite right. Here is a shortcut to get descriptive statistics for any variable. In Data View, right-click or Control-click on Mac on the variable name and choose Descriptive Statistics. The output window pops up with a single table telling us the most important statistics about that variable. Now, this technique can also be used in variable view by right-clicking on the name of the variable. For scale variables, you get basic descriptives, including the mean and the standard deviation. For categorical variables, you get mode and range and a frequency table. The advantage to this technique is that it is quick and easy. The limitation is I can't choose which descriptive statistics are provided, and I must examine each variable separately. As we did with categorical variables, we can create numbers, tables, and pictures for scale variables using the Frequencies menu. Click on Analyze, Descriptive Statistics, Frequencies. Move both scale variables into the variables box by clicking on the variable name and then the arrow between the boxes. Now, click on Statistics. We have options for central tendency, such as the mean, median, mode, and sum. We can check the dispersion or variability with the standard deviation, variance, range, minimum, maximum, and the standard error of the mean. We can check the shape of the distribution by examining skewness and kurtosis. If we ask for percentiles, we need some additional settings, but we can also get percentiles by asking for equal cut points equal to 10. Click Continue. That will give us numbers. We can get our pictures by using charts. For categorical data, we used a bar chart, but for scale data, we will use a histogram. Let's also choose Show Normal Curve on Histogram. Notice that the chart values are now gray because we will not need them. Click Continue. We get frequency tables by default in the Frequency menu. Frequency tables with continuous data are notoriously unsatisfying, but I'm going to show you how to fix that with visual binning. We will not need any of the options under Format, Style, or Bootstrap. Click OK to run the descriptive statistics, and the output will give us the numbers side by side for both of our distributions. We have descriptive statistics, variability, distribution measures, percentiles, but it took a lot of clicking to get here. And of course, you could select fewer options, focusing just on the ones that you actually need. So scroll down and let's have a look at the histograms. The difference between a bar chart and a histogram is that in a histogram, the bars touch. In a bar chart, we see gaps between the bars. By adding the superimposed normal curve, we can explore the shape of the data. The number of dog toys owned is skewed to the right, called a positive skew. And it has this one score out by itself, which is called an outlier. We will look at the outlier again with the Explore command. The number of days until failure looks fairly normally distributed. We will check that later using normality plots. Okay, back to our frequency tables. The frequencies for continuous variables are 20 rows long, and obviously that is too long to use. If we want frequency tables with continuous scale variables, the best solution is to bin them, to group the scores into bins or categories. To create bins, we will transform the scale variable into a new binned variable while keeping the original scores. Go to Transform, Visual Binning. Move both scale variables into the Variables to Bin box, and then click Continue. This procedure creates a new variable that we will call Toys Owned Bin. Both variables range from 1 to 20, and I want to create 5 bins. Each bin will be 4 units wide, 1 to 4, 5 to 8, etc. And I want the bins to include the upper end points. Click on Make Cut Points. We can create cut points or divisions between the bins based on the standard deviations of the data or percentiles from the data itself. But I want to create 5 bins that are 4 units wide, so I will choose equal width intervals. Because I want 5 bins, I will select 4 cut points. The number of cut points always equals the number of bins minus 1. I said that I want the bin width to be 4. SPSS fills in the remaining field. But I don't want the first cut point at 1. I want it at 4. Click Apply. The values for the cut points look right, 4, 8, 12, 16. But I would prefer to have some descriptive labels for my bins. Click on Make Labels. The labels are pretty close. This will save me some time, but I want to clean up these labels so that the first one is 1 to 4. And the last one is 17 to 20. And because the other scale variable is also in the range of 1 to 20, I can copy these settings. Under Copy Bins, click on Two Other Variables. The other variable is Days to Fail. Click Copy. I will want to give this second new variable a name. And now click OK. We see that the 2 new variables will be created. Good. Click OK. The new variables are added to the bottom of our variables list in Variable View. We can get a quick peek at them using our right-click on Descriptive Statistics trick. If you want only the numbers describing your variables, and you do not need frequency tables or graphs, the Descriptives menu will save you some clicks. Go to Analyze, Descriptive Statistics, and choose Descriptives. Move each scale variable into the variables box by drag and drop, or by double-clicking. Now select Options. The most common descriptive statistics are already selected. Just for grins, let's select all of the others so that we can see what they do. When you are describing multiple scale variables, the Descending Means option organizes the output by placing the variable with the largest mean first, and then the rest in descending order. And this can be very useful for comparisons. Click Continue. The Descriptive menu also allows us to standardize variables by turning each data point into a z-score. Click on this box, Save Standardized Values as Variables. We will not do anything with style or with Bootstrap. Now click OK. Instead of placing the descriptive statistics in columns, the Descriptives menu gives us the output in a horizontal table. We see the minimums and maximums. Collectively, the 50 dogs in our survey own a total of 304 toys. We have means, standard deviation, skewness, and kurtosis, which of course tell us about the shape of the distribution. There are no graphs or frequencies. Look at the variables list again in the data set. You will notice two new variables at the bottom of the list. They are called Z, toys owned, and Z, days to fail. And do you know what those are? Those are Z-scores. SPSS converts each measurement into a standardized score that tells us how many standard deviation units this score is away from the mean. Right-click on Z Toys Owned, Control-click on Mac, and choose Sort Descending to put the largest score at the top. Z-score values greater than positive or negative 3 indicate outliers. This Z of 3.7 further suggests that we have an outlier in this data set. Well, you may have wondered why I keep mentioning that outlier. In another video, I'm going to explain to you about testing assumptions and how to check for them. But for now, just know that outliers can be a problem, so we need to know how to recognize them, and I'm going to show you a few techniques for checking assumptions using the Explore command. Click on Analyze, Descriptive Statistics, Explore. Move the variables for number of dog toys owned and days to fail into the Dependent List box. Click on Statistics. Instead of a long list of options, the Explore command will give you a specific set of descriptives. This makes our exploration quicker. Also, check for outliers. Continue. Now click on Plots and choose Normality Plots with Tests and turn on the histograms. Now click Continue and OK. As the output pops up, think about how few clicks it took to get these descriptives. In the Descriptives box, you see all of the familiar descriptive statistics, means and trimmed means, measures of dispersion, and the shape of the distribution. Scroll down. We already know that we likely have an outlier in the toys owned. The Extreme Values box identifies the 5 highest and 5 lowest scores for each variable. Because we sorted the data, it looks like case number 1 is the outlier. Some dogs just have a lot of toys. Outliers will affect the normality of your distribution. Both the Kolmogorov-Smirnov and the Shapiro-Wilk are tests of normality. If the significance values are low, that means that the distribution is not normal. Clearly, the number of dog toys owned deviates from normality. But the days to failure variable passes the test for normality. Scroll down and you see a series of plots. Notice the difference between a normally distributed variable and a right-skewed variable in the histogram, the QQ plot, and the box plot. If you plan to do some comparisons between groups, such as the 3 breeds of dogs, you should check the assumptions for each level of the categorical variable separately. Recall the Explore command by clicking on the Recall Recently Used Dialogues icon. Notice that we have access to all of the recently used dialogues. Click Reset to clear out the previous analysis. We are going to use the days to fail variable for this example. This time, we want to examine the descriptive statistics about days to fail for each breed of dog separately. Move the nominal variable, breed of dog, into the factor list. Now click OK. We see the descriptive statistics have been calculated separately for the three types of dogs. We now have separate stem and leaf plots for each breed. And the box plots are now side by side so that we can do comparisons. The dark lines in the middle of the box are medians. But there is a different way that we can compare means. Click on Analyze, but instead of Descriptive Statistics, choose Compare Means. And this first option, simply labeled Means. The dependent variable refers to our scale variables. We will examine both days to fail and toys owned. The layers refers to the independent variable, or the categorical variable, breed of dog. Because we don't actually assign the dogs to be a certain breed, we just record them for whatever breed they are, that is called a quasi-independent variable. Click on Options. We will use the default descriptive statistics. Click on ANOVA Table and ATA. Click on Continue and OK. The report shows our descriptive statistics for both scale variables, split by the three breeds of dog. Being side by side, they are easy to compare. Below that, we have an ANOVA table. We will learn about ANOVA later, but for now, let's just examine those significance values. We are looking for numbers smaller than 0.05. For number of dog toys owned, the value is 0.508, which is larger than 0.05, and therefore not significant. There is no difference in the number of dog toys owned between breeds. For days to fail, however, the p-value is less than 0.001, so it is statistically significant. There is a difference in how many days before a toy gets chewed up, based upon the breed of dog. Recalling our box plots, retrievers kept their toys intact the longest. Fuzzy dogs second, and the Chihuahuas chewed up their toys the quickest. We would need to do a follow-up for this test, called a post hoc, but for now, you already have an idea of how we could use the descriptive statistics in this course. So let's review what you've learned. You understand scale variables and how they differ from categorical variables. You can create a bind variable from a scale variable. You have seen multiple ways to get simple descriptive statistics. The frequency command gives us lots of options and produces histograms. The descriptives command is simple and it creates z-scores. The explore command is fast and highly detailed, and it allows us to split a scale variable by a categorical variable or to do assumptions testing. And next time, we will create a code book and learn how to work more extensively with the SPSS output.